Hi, we're going to get into Unit 5, which is going to be talking about changing decimals to fractions, and then we're going to go to another section of this very same video of changing fractions to decimals. The steps in changing decimals to fractions is you're going to determine the place value of the last number in the decimal, and this becomes your denominator. The second step we're going to do is the decimal number is in the numerator, and then you're going to reduce it down into the lowest possible terms. Tip, if you need to do this, and I always do it, read the decimal out loud as you write it. Now, when we're in class, I don't mean everybody is just reading out decimals, but you can read it out loud to yourself, kind of sort of write it out, read it quietly to yourself as you write it out. For example, this decimal is 625 thousandths, because this is tenths, hundredths, thousandths place value. It's where the last digit is, so it's 625 thousandths. And if I were to write this in a fraction, it would be 625 over 1,000. Now, I do know, because one number ends in 25 and the other one ends in 0, that 25 can go into both of these. 5 would go into it, but I know, because this is 625 and this is 1,000, that 25 will go into it. Remember, you're going to use your decimal number as your numerator. So I'm going to divide 25 into both of these, and when I do, I'm going to get 25 over 40. Now, I know with the place value of 5 and 0, knowing my divisibility rules, that 5 will go into both these two numbers. So 5 will go into both 25 and 40. 5 goes into 25 5 times, and 5 goes into 40 8 times. 5 eighths cannot be reduced any further down, so this is going to be the equivalent fraction for 625 thousandths. All right, let's do some of these together. If I look at this one, I know that I have got 12 thousandths, because this is tens, hundredths, thousandths. So I've got 12 thousandths as my new fraction. Now, I know, because one ends in 0, the other one ends in 2, that 2 goes into both of these because they're even numbers. So I'm going to divide each one of these by 2, and I know that this is going to equal to 6, and I know that 2 goes into 1,500 times. Now, if you notice, I know that they're still even, so I know 2 can go into both of these again. So let's keep dividing out until we have a number that we know is going to be in its lowest term. 2 goes into 6 3 times, and 2 goes into 500 is going to be 250. And I know that 3 cannot go into 250, and 3 times 1 is, those are the only factors of 3, so it's going to be 3 over 250 is going to be my fraction equivalent. Now, this one has got a whole number with it. And what you can do here is, I know that I've got 1 as my whole number, and then we're going to read the decimal part as 45 hundredths, because the 5 is in the hundredths place. So 45 over 100. And always remember to take that 1 with you, because that is a whole number 1 and it goes with the problem. But I know I can divide both of these out with a 5. 5 goes into both of the numerator and denominator. So 5 goes into 45 9 times, and 5 goes into 100 20 times. So I know that this is going to be 1 and 9/20ths, and nothing else will go into 9/20ths, so it's reduced down. Again, I've got 7 and 6 tenths. So I'm going to write it as 7 and 6 tenths. Okay? I know 6 tenths can be reduced because they are both even numbers. So I'm going to write my whole number 7 down. I know that 2 will go into both of 6 and 10 evenly. So this will be 7 and 3/5. And that is in its reduced form. Why don't you go ahead and pause the video and do these two on your own, and then check it, come back and play it again and see if you've got the same thing that I have. This is going to be 5 hundredths, because this is in the hundredth spot. This is tenths, hundredths. So I'm going to reduce both of these down. Both of these can be divided by 5. So this is going to be 1 over, 5 goes into 100 20 times, so that's going to be 1/20th, and I know that's in reduced terms. Here I've got 658 thousandths, so 658 over 1,000. I know they're both even, so I'm going to divide 2 into both of these. And I know that 2 will go into 658, 329 over 500. And I know that there's nothing that goes into 329 and 500. You can try it if you want to see if it can be reduced down anymore, but this is going to be 329 over 500. So this is how you're going to be changing a decimal into a fraction. Now, let's look at something, our next step. Now, we're going to change a fraction back into a decimal. How we do this is we're going to divide the numerator by the denominator using long division, and we've already done this. So we're going to tip, you can read this to yourself as well. So read your fraction out loud as you did as you set up the long division problem. Now we've always talked about you start from the top and you're going to read it down. This fraction bar is actually a divided by sign. So it's 5 divided by 8 because a fraction is nothing more than a division problem. So we're going to say 5 divided by 8 is how we would read it. So we're going to come over here and say 5 divided by 8. I'm going to go ahead and put my decimal up here at the top. Notice I put a 0 above the 5 because 8 will not go into 5. But if I add a 0, I know that 8 will go into 50 48 times when I have 6 times, because 6 times 8 is 48. And I'm going to subtract this. I have 2 left over. I have to add a 0, bring it down. 8 goes into 20 2 times. 2 times 8 is 16. Subtract 16 from 20, that gives me 4. Add another 0. Remember, we can add all the zeros we want to. It's not going to change the value of our number. So when I add a 0 to 4, I have 40, and I know that 8 will go into 40 exactly 5 times evenly. So 5 times 8 is 40 with nothing left over. So 5/8 is the same thing as 625 thousandths. Very important concept, number 1. Anytime I'm working with mixed numbers, you want to change those mixed numbers into improper fractions before you start dividing first. Let's do some examples. If I'm going to read 3 divided by 8, it's going to be 3 divided by 8. And I know that 8 will not go into 3, so I'm going to place my decimal up here, and I'm going to put a 0 because it will not go. But if I add a 0 to it, 8 will go into 30 3 times. 3 times 8 is 24. 30 minus 24 is going to give me 6. Add a 0 and bring it down. What times 8 will give me 60? Nothing is not going to give it to me individually, but I know that if I say, let's say 8 times 5 is 40, 8 times 6 is 48. How about 8 times 7 is 56? So I know that 60 minus 56 is 4. Bring down a 0 like we have been doing in the past. And I know that 8 will go into 40 exactly 5 times. So 5 times 8 is 40. And when I subtract that, I have nothing left over. So the equivalent decimal for 3/8 is the same thing as 375 thousandths. Again, here, remember, I have to change it into an improper fraction because I have a mixed number. Now you can do that, or I'm going to show you another way on the next one. But let's go ahead and do that by saying 6 times 1 is 6, plus my 5 is going to be 11 over 6. This is the improper fraction for 1 and 5/6. Now I can read it as 11 divided by 6. I know that 6, let's go ahead and put the decimal in there, will not go into 1, but it will go into 11 one time. And I'm going to put it over the last digit in the ones column of the 11. Don't put it over here in front of the 1 in the tens column. So I'm going to say 1 times 6 is 6. I know that 5 minus 6 is 5. I've already added my decimal and placed it up here in my quotient. I've added a 0. Let's bring it down. It's now 50. 6 times what will give me 50? Nothing's going to go in there evenly, but I know that 6 times 8 is 48. Subtract that, so 50 minus 48 is 2. Add a 0 and bring it down. 6 goes into 20 3 times. 3 times 6 is 18. If you notice what happens, I have 2 left over. I can continue adding zeros, but you should see now that it's going to just keep repeating the 3. So if I had a 3 here, I know that's going to work. If it's just going to keep going 3, 3, 3, erase all these 3s, and we're going to put a repeating bar over the 3. The only thing that's repeating is the 3, and that is the only one that gets the bar over it. We're not going to put it over the 8. We're not going to put it over the 1. We're just saying that the 3 in this number is going to continue on repeating as long as we continue to divide out. All right, number 3, 7 divided by 20. Let's check this out. I know that 20 will not go into 7, so I'm going to place my 0 behind my 7, bring it up into the quotient. I'm going to add a 0. I know that 20 goes into 70 3 times. 3 times 20 is 60. 70 minus 60 is 10. Add a 0, bring it down. How many times will 20 go into 100? Exactly 5 times, because 5 times 20 will give me 100. So this is going to give me 35 hundredths. So 7 20ths is the same thing as 35 hundredths. Let's do one like 4/5. We're going to say 4 divided by 5. I know that 5 will not go into 4, but if I place a decimal over here, add a 0, I know that 5 will go into 40. 8 times 5 is 40, so I know that this is going to be 8/10. So 4/5 is the same thing as 8/10. Now remember last board I told you that I would show you another way of doing this. It might be a quicker way. Instead of changing this into an improper fraction, I already know that 2 is my whole number. So let's put a 2 and a decimal there. Now the only thing I have to worry about now is the 30 hundredths. I do know that I can go ahead and divide out and simplify this fraction before I even start dividing out. I know that 10 goes into both of them, so I can cross out my 2 zeros, okay? One in the numerator, one in the denominator, and now I've got 3/10. It's a lot easier to divide 10 into 3 than it is 100 into 30. So let's go ahead and divide out 10 divided into 3, or 3 divided by 10. Put a decimal in, put it up into my quotient. And I know that 10 will not go into 3, but if I add a 0, I know that 10 goes into 30 3 times, and that's going to give me 30, and 30 minus 30 is 0. So I know that 0.3 or 3/10 is the same thing as 3/10 in this decimal form. All I have to do is come down here and add the 3 in behind the decimal, because it's 0.3, there's a 0.3, and all I did was bring down my 2 because I know 2 is the whole number. If you have any questions about this, we're going to be doing lots of operations in class, and I will talk to you then.